In this video, we are going to discuss linear inequality, number line, and interval notation. So first of all, let's discuss the four inequality sign. The first inequality sign is a greater than. So this is a greater than. So how do we use a greater than? Let's say 10 is greater than 5, 3 is greater than -7. So that is a greater than. And then this sign is called a less than. So -3 is less than 20, 9 is less than 25. That's how we use the less than. And then the next one is greater than or equal to. So here is how. 4 is greater than or equal to -3. 4 is not equal to -3, but 4 is greater than -3. So when you use a greater than or equal to, as long as the greater than or the equal to is satisfied, then the inequality is true. Okay, as long as the greater than or the equal to either symbol is satisfied, then the entire inequality is satisfied. You can do 5 is greater than or equal to 5. 5 is not greater than 5, but 5 is equal to 5. So the equal is satisfied, then the inequality is satisfied. The next one is less than or equal to. So let's say we have a -10 less than or equal to a 6. So -10 is not equal to 6, but the less than is satisfied, then the entire inequality is satisfied. You can do 7 is less than or equal to 7. So 7 is not less than 7, I know, but the equal is satisfied, then the entire inequality is satisfied. So what is inequality? Inequality is a mathematical statement containing one or more of the inequality symbol. So let's say we have x plus 5 equals to 12. So this is an equation, definitely not an inequality, right? So we call this an equation. So inequality, we do x plus 5 less than 12. So this is called an inequality. And then how do we solve that? So just treat that as an equal. So to solve this, we want to isolate x on the left hand side. That means we want to subtract 5 on both sides. So x is less than 12 minus 5. X is less than 7, right? So x is less than 7. This one, we don't call this a solution. So when back to an equation, x equals to 7 is called a solution, because 7 plus 5 is equals to 12. But x less than 7, we call this a solution set, because this is a set of numbers. So why do we call this a solution set? Because what kind of number satisfies the inequality as long as the number is less than 7. So we have a list of numbers. So let's say 6, 6.5, 6.2, 4, 0, -10, so on and so forth. So the solution set is a set of number. It's not one individual number. X equals to 7 is one individual number. That's why we call this a solution. For inequality, the final answer, we call it a solution set. So it's a set of number. So one of the ways to write the solution set is using inequality. The second way to do it is using a number line. So do you see that there is a number line right here? So this is a number line. Do you see there is a blue line? So I cut the blue line into two pieces. I put a red 0 right in the middle. The 0 is called origin. It's right in the middle. And then I have positive number on the right and negative number on the left. So let's look at the positive number first. So we have 0, 1, 2, 3, 4, 5, 6, ... right? So why do I use a ... Now, tell me, what is the biggest value that you can put on the right hand side? What is the biggest positive integer you can think of? Positive integer, the biggest quantity ever. Think about it. Is such number exists? No, right? So there is no biggest integer, so therefore there is no biggest. I use ... because the right hand side, the number line, extends all the way to the right. But what exactly is on the right hand side? So that is a positive infinity. So what is positive infinity? So positive infinity is a positive, right? Infinity, so it's like an 8, but we put the 8 on sideway, right? So positive infinity, that means a quantity that is positive and extremely large. But we don't have such number. It is impossible to write this number on a piece of paper. So since we can't do it, in math, we don't want to say we can't do it. So since there is no such number, we don't know what that number is. It's really, really big, but there is no biggest. So there is no biggest. We use a symbol called positive infinity to represent this. Right? There is no such thing. We can think of this. All right. So we use positive infinity. So positive infinity is not an exact value. That stands for a quantity that is positive and extremely large. All right. Let's take a look at negative. -1, -2, -3, -4, right? As you move to the left-hand side, the numbers are getting more and more negative. As you move on to the right-hand side, the numbers are getting bigger. They are getting more and more positive, right? So what exactly is on the left end? Just like the right end, there is no such number on the left end, so we use negative infinity. Negative infinity is a quantity that is negative and extremely large, all right? Negative and extremely large. We don't have such number, just like the right hand side. So therefore, mathematicians said, why don't we just use negative to represent that? We don't know what it is. We cannot write such number on paper. Fine, we use a symbol called negative infinity. Just like the unknown, x. You don't know that, fine. We use x. Instead of writing the word unknown or don't know, we use x. So that's math. So that's the number line. And then how do we graph a solution set on, that is the number line. How do we graph a solution set on a number line? So first of all, I have to introduce a solid circle and a square bracket. What does that mean? That means including the indicated number. So let me try to graph x less than or equal to 5 on this number line. So what I am doing is I have x less than or equal to 5. So that means x can be equal to 5. So therefore, I put a solid circle on 5. And then what kind of number is less than 5? Remember this, small number on the left, big number on the right, small number is on the left. So that is the graph of x less than or equal to 5. Don't worry about the interval notation yet. Don't worry about the square bracket yet. We will do that next. And then the next one is x greater than or equal to -4. So here is -4. We have a greater than or equal to, the number greater than -4. They are on the right hand side. So we shoot an arrow to the right. What about interval? So here is how we represent interval. So 5 is a positive, right? So we draw a 5, and then x can be equal to 5. So we use a square bracket. That means including the 5. What is on the left hand side? So negative infinity is on the left hand side, right? So we draw a comma, and then this negative infinity. Should I include negative infinity? The answer is no, because you don't know how big that is. So that's why we use a parenthesis. Parenthesis means we do not include that number. So this is called an interval. We need to use interval in statistics. So interval has a small number on the left, big number on the right. So small on the left, and then bigger number on the right. Always small on the left, big on the right. That is just like how the number line works. You see small number on the left, big number on the right, right? And then what about x greater than or equal to -4? So since we use a solid circle for -4, so that is a square bracket, -4, and then to positive infinity, so we don't know exactly how big that is, we use a parenthesis. So that's how we do the number line and the interval. And then next one, open circle. Open circle means do not include the indicated number. So this time we have x less than 5, no equal. So what's the difference between the less than and the less than or equal to? So here is the difference. For the less than only, you use an open circle. Don't fill out the circle because x cannot be equal to 5. And then less than, small number on the left. So that is how you graph this solution set. And then what about interval? So interval, this time we go from negative infinity to 5, but parenthesis on both because we don't include 5. And for negative infinity, we do not know the exact value of negative infinity. Greater than 4, greater than -4, so do not include -4. And then shoot an arrow to the right. Because this number, every single number right here, they are all greater than -4. So this will be -4 to positive infinity. Parenthesis on both because we do not include -4 for infinity. Doesn't matter positive or negative. We always use parenthesis. All right, and then real number line and interval notation. So we have some exercise. I want you to read the statement, write the inequality, put the inequality on the number line, and then give me an interval. So the first one is x less than or equal to negative 5. So x less than or equal to negative 5. So here is negative 5. And then less than or equal to is there, right? So the interval is from negative infinity to negative 5 square bracket. Always small number on the left, followed by a comma, and then big number on the right. Greater than or equal to 8. So that is x greater than or equal to 8. This is x greater than or equal to 8. Shoot an arrow to the right. So that is 8, including 8 to past infinity. What about just x greater than 8? So just x greater than 8. So this is 8, right? No equal, just greater than 8 only. So we use an open circle. And then shoot an arrow to the right because every number on the right is greater than 8. So the interval is from 8 to positive infinity. And then less than or equal to 0, x less than or equal to 0. So that will be this 0, including 0. And then every number on the left-hand side of the number line is less than 0, right? This number, they are all less than 0. So this one is from negative infinity to 0. One thing that I don't want people to do is this. So we have less than or equal to 0, right? Suppose you are writing this on a piece of paper. Do not do this. This one makes everything tough to grade. So let's say you have nothing, right? You have a blank piece of paper. I want you to graph that, and then you draw a number line. And then you draw a 0, right? One thing that I really hate is people put a dot on the line and then put an arrow like this. If you use a pencil, that makes everything very tough to grade. I don't want you to draw on the line. I want you to put that right above the line. I want you to do this so I can see it. So there is a solid circle. There is an arrow. I can clearly see what's in there, right? Don't draw on the line. So when you sketch your own number line, you don't have to do the 1, the 2, the 3. Just put the number that we want to see. You don't need to write everything else. So you don't need to do -1, -2. That is not necessary, right? Okay, 2 more. Between -6 and 3, including -6, including 3. Let's graph this first, including -6, right? So that will be including -6 and including 3. Between means I need the numbers between them, right? Here is -6, here is 3. These numbers are between them. How about the inequality? The inequality is, so this is how we write it, -6 less than or equal to x less than or equals to 3. So let's say x equals to 0. So 0 is greater than or equal to x, 0 is less than 3. So this is called a compound inequality. You also need this in statistics. Compound inequality, one line with 2 inequality symbol. And then the last one is between -5 and 10, not including -5, but including 10. So no -5, but including 10. So this is a solid circle. So we have -5 less than x, because solid open circle, right? Then we don't do an equal, less than or equal to 10, and then the interval, parenthesis for open circle, square bracket for solid circle. And then the one above that, solid circle, square bracket for both. Remember, small number on the left, big number on the right. So that is the basic concept of linear inequality, number line, solution set, and interval notation. So in the next video, I will show you how to solve simple inequalities. All right, I will see you all in the next lesson. If you think this lesson is helpful, like, subscribe, and share. I appreciate your help really much. I see you all in the next one. Signing out for now.